by siphoning water from a large container at one height or another. We can vary the height of the container. We can allow fluid to flow through this system, and out this end we can measure the flow rate easily, catching water in a graduated cylinder, timing it. We can vary the length of tubing between these 2 points. We can vary the diameter of the tubing, and we can observe the pressure difference as a difference in vertical levels between these 2 tubes. And we can establish a relationship between, or the relationship among length of tubing, diameter of tubing, etc. But more importantly, we can get the concept of resistance. Basically, longer tube, more resistance to flow. Less diameter, more resistance to flow. Allows us to use different lengths of tubing to simulate, well, to actually achieve different resistances, which can be put in series and parallel with a very tangible measure of pressure difference at any point we choose. Okay, simply using inexpensive T's and other connectors. It's occurred to me in thinking of different experiments we might want to do if we're going to look at the hydrodynamics, that some sort of a circuit board might be appropriate. So this is a fairly obvious construction. We have an inlet here, we have an outlet down here, and in between we have a number of different points at which we can connect tubing of various diameters and lengths. Right here we have a series connection that runs from here to here. Just cap off this end here, cap off this end here, and the opportunity for the parallel circuit. Well, we're not going to use that opportunity if this is all we want to do, but of course then we can hook in parallel combinations and have a whole lot of flexibility here. The connections at the ends are with tubing of fairly large diameter and short lengths, so that there's going to be very little pressure loss in those tubes. So there's very little resistance in these tubes, although there will be some that we might be able to measure by looking at the height of the fluid in these 4 vertical tubes. Lost my train of thought. Still don't know what I was about to say, but clearly the system has a lot of possibilities, an endless variety of tube lengths, resistances, pressures, etc. Of course, we can get longer tubes here if we go to higher pressure. These things are very inexpensive, and we can deal with the curvature of these tubes. Didn't have time to do that in the 24 hours that I've been thinking about this.